Okay, in this problem, we're being asked to find dy dx given e raised to the 2y times sine of 3x equals 4 plus cosine of x squared y. So we're going to have a lot of things going on within this problem. We have e raised to a power, so we have an exponential rule, we have a trig function, we have a product rule, and on this side, we have again another trig function. And then within that, buried within that is also a product rule. So a lot of different things going on within this problem. So let's see if we can take this sort of one step at a time. I'm going to take d dx of both sides. Again, always making sure you balance. So whatever you do to one side, you do to the other. And we're going to slowly start looking at this. So I'm going to take the derivative of, because this is a product rule, derivative of the first, I'm going to leave the second one alone, plus the derivative of the second, leaving the first one alone. So that's our derivative of uv is u times derivative of v plus derivative of u times v. So derivative of e to the 2y would be e to the 2y. And now the derivative of this piece will give me 2. But because these letters don't match, I also get dy dx. And the sine 3x stays exactly the way it was. And we're going to add. Now I'm going to leave the first one alone. So the e to the 2y is sort of left alone. And now I'm looking at what's the derivative of sine of 3x? Well, the derivative of sine would be cosine. And the derivative of 3x would just give me 3. And because these letters do match, I don't have to worry about the implicit piece. Now, what happens on the other side of this? So for right now, I'm going to go ahead and write it below just because it's kind of big, but I'll put it in a different color for us. So the derivative of 4 is going to give us a 0 plus the derivative of cosine. Well, the derivative of cosine is actually negative sine of x squared y. And now I have to do the derivative of this. So again, product rule of the interior. So the derivative of x squared would be 2x. Letters match. So we just end up with 2xy. And, oops, I'm going to undo that part. I'm going to put plus. I'm not going to do the derivative of the second one. So the derivative of y would just be 1. And then I have my x squared. And because these don't match, I now end up with a dy dx. So a lot of little things here that we're going to have to try and maneuver and clean up in this problem. So let's see if we can kind of do this one piece at a time. Put this in a color where we can clean this up a little bit. So on this piece here, this now gives me 2 e to the 2y sine of 3x all times dy dx. This part here is going to give me plus 3 cosine of 3x. Actually, we could probably put that e to the 2y after the 3, but we'll leave it there for now. And then on this side here, 0 is going to go away. We're going to kind of clean this up a little bit by distributing some things out. So I'm going to multiply this out here. I'm going to go ahead and put in one more color here. So I've got negative 2xy sine of x squared y minus, distributing it again out, minus x squared sine of x squared y dy dx. So you can see how this is kind of getting sloppy to look at, but we just have to keep track of each individual piece here. So our goal is really going to be now to try and figure out how do I get this dy dx and this dy dx on the same side, and at the same time, how do I go ahead and move this piece that has no dy dx over to the other side with the piece with no dy dx. So we've got some cleaning up to do. So I'm going to go ahead and subtract this side over. I'm going to add that one over. And so our next step should look like this. We should now have 2e to the 2y sine of 3x plus x squared sine of x squared y. And all of that is my dy dx. And on the other side, I will now have the negative 2xy sine of x squared y minus 3e to the 2y cosine of 3x. So everything with a dy dx on the left, everything without on the right. And now how do I get dy dx, this piece right here, by itself? Well, here's where we divide both sides by that term. So we're going to divide both sides by this. So on the left, I'll have dy dx. And on the right, I'm still going to have what I had before. So I'm going to have my negative 2xy sine of the quantity x squared y minus 3e raised to the 2y cosine of 3x. And that's all divided by this big blob right here. So 2e to the 2y sine of 3x plus x squared sine of the quantity x squared y. And again, these can be moved around. Negative signs can be factored out. Things can be switched a little bit, but that's basically our answer to this problem. Dy dx is equal to those two quantities divided.